This is 10.4, surface area and volumes of similar solids. And a similar solid, they have the same shape and have proportional corresponding dimensions. So that means heights are proportional, radiuses are proportional, other side dimensions like that. So we're going to determine which cylinder is similar to cylinder A. So we're going to see which B or C is going to be proportional to A. So to compare A and B, we are going to compare their heights. So I'm going to put the height of A over the height of B, and that's 4 over 7. And I'm going to compare the radius of A to the radius of B, and that is 6 over 8, which reduces to 3/4. These aren't the same numbers in the fraction, and I can't reduce them any further, but we can look at their decimals to see, and this one will be 0.57, and we know 3/4 is 0.75. So 0.5, 0.7, those aren't the same either. So these are not the same, cylinders are not similar. So we're looking to see if these two fractions are going to be the same. Now we're going to compare A and C, and are these ones similar? So the height of A over the height of C is 4 over 5, and the radius of A over the radius of C is 6 over 7.5. These also are not the same fractions, but if I look at their decimals, 4/5 is 0.8, and 6 over 7.5 is also 0.8. So these are the same, and so we can say the fractions are equivalent, so the cylinders are similar. Now we have a couple different ways on how we can set up proportions for our figures. We can put dimension, they're all going to be dimensions. We can either put the same figure on top with the same dimension lined up, or we can put the same figure on top and bottom, and then the same dimension side to side. So that would look like these two options, where we have A over A, B over B, height on top, radius on bottom. Or we can have height over height, radius over radius, A on top, B on bottom. Either one of these is going to get you the right answer, as long as you plug in the numbers correctly. And I wouldn't really say one is easier than the other. It's just a preference, or which one just feels a little more natural to set up when looking at your problems. So let's do a couple examples. We're going to find the missing measure of the solids. So I have two cones here labeled X and Y, and I'm going to put the radius of X over the radius of Y equals the slant of X over the slant of Y. So the slant is this side. It is called the slant height. And the radius of X is 5, radius of Y is 7, so I have 5 over 7. The slant of X is 13 over the slant of Y, which we called L. That is a cursive L, which we use instead of a regular printed L, because a regular L looks like a 1. So we're going to cross multiply to get 7 times 13 is 91, 5 times L is 5L, divide each side by 5 to solve for L, and 18.2 is the missing measure. And we have our two rectangular prisms here, A and B, and this one's also set up height over height, width over width. And plugging in those numbers, cross multiply, 9 times 2 is 18, 3 times h is 3h, divide each side by 3, and the height is 6. If I am given the surface area of a figure, I can find the missing dimension, or if I know the dimensions, I can find the missing surface area. So surface area of A over surface area of B is the dimensions of A over B squared. So here, I'm going to find the missing surface area of figure B. So setting it up with surface area and height is what I'm given as my dimension. I'd have 600 over B equals 10 over 6 squared. 10 over 6 squared is 100 over 36, cross multiply, and solve for B to get B is 216. And I could also do this if I am given volume. The dimensions are going to be cubed when dealing with volume. So we're going to find the missing measure here between the cones of A and B, putting in the volumes and radius for each, plugging in the numbers. 5 cubed is 125, and 12 cubed is 1728. Cross multiply, and then we're going to divide and solve for A. So the volume of A is 20.3. So it's quite a bit smaller than the volume of B. And here we have two square pyramids, and I don't know the volume of B, but I do know the volume of A. So I'm going to plug in the numbers that I know. I'm going to leave B as B. And 3 cubed is 27, 4 cubed is 64. Cross multiply, 9 times 64 is 576, and B times 27 is 27B. And then to get B by itself, we do the opposite of multiplying by 27, so we divide each side by 27, and we get 21.3 is the volume of B. So the dimensions of a kiddie pool are doubled. How many pounds of water are contained in the new pool? 1 cubic foot of water weighs about 62.5 pounds. Okay, so let's see. We have the old kiddie pool here has a volume of 2,000, and we know that the old volume compared to the new volume is 1 to 2 because the dimensions are doubled. So if the old dimension, everything in there is 1, the new one, everything is going to be worth 2. So I'm going to plug in my old volume, new volume, cube it. So that's 2,000 over n equals 1/8, because 2 to the third power is 8, 1 to the third power is 1. Cross multiply, and I get 16,000 is 62. Yes. So cross multiply here, 1n equals 16,000 cubic feet. And we're told 1 cubic foot of water weighs about 62.5 pounds. So for every one of these, I have 62.5. So we multiply to get 1,000,000 pounds. That's a pretty big kiddie pool.